Good day, everyone. I'd like to introduce you to a breakthrough technology. As you can see on my screen, synchronous technology. Feature function has always been a CAD-related tool that forces companies into a particular CAD methodology. Today, I wanted to introduce you to Solid Edge with synchronous technology. Synchronous technology from Siemens PLM software connects everyone in the product life cycle, and it connects them all without limitations. Connection without limitation, freedom with coordination, that's how synchronous technology helps you innovate more and makes your design process 100 times faster. Today I'm going to show you how to improve your design process 100 times faster. Because with synchronous technology, you no longer have to choose between constraint-driven and history-free modeling. You no longer have to be a programmer to reuse a model. You no longer need to worry about using data from multiple CAD systems. So I have one question to ask you. Can your current CAD solution truly operate without constraints in a multi-CAD world? Are you ready for the next big breakthrough in digital product development? On behalf of Innovative Solutions and Siemens PLM, let's take a look. As you can see here, I have my Solid Edge screen. One of the big things I want to show you is everything we can open. And when I say multi-CAD environment, we truly mean multi-CAD environment. From Solid Edge and Unigraphics to AutoCAD, Catia, Inventor, Pro-E, SolidWorks, STEP, STL, SAT, Parasolids. We truly can open every CAD system that is available out there today to truly allow us to work in a multi-CAD world. What I'd like to do is I'd like to start by showing you a Pro-E document. If you were to receive a Pro-E document today and you weren't a Pro Engineer user, how would you handle that model? Let's take a look. I'm going to go ahead and open this model up. And you see that the program will run a translation in the background. It takes a few seconds, and the model is ready for us to take a look at. In all other CAD systems, the issue that would occur here is the model appears as a dumb model. And what we mean by a dumb model is there's no features here. In an order-based world, feature-based modeling, you need to have features to be able to edit. Now, some CAD systems have put Band-Aids on in order to allow you to make some changes. But what if it was simple? What if it was easy? What if I can truly show you how to make changes quick and fast? Well, the first thing is, let's take a look at how we would handle this in a feature-based system. Looking at this particular area here, I need to decrease this distance from here to here by 1 inch. In addition to that, on the floor they realized for better mounting capabilities that I need to increase the hole sizes on this particular holes. I need to increase them to 0.1875 from its current hole size. I also need to move these holes 1 inch to the right. In addition to that, I need to increase this depth by 1/8 of an inch. And last, I need to eliminate this angle and square it up with this current feature here. So how would you do that with your current CAD system? What methodology would you go about in order to make that change? Well, let me show you how we'd handle it with synchronous technology. First thing is I need to decrease this by 1 inch. I'm going to make a selection. I'm going to grab the steering wheel here. I'm going to move it down to where we want to move this to, and we're going to go ahead and decrease this by 1 inch. Done. Next step, holes. I'm going to go ahead and grab this hole. I'm going to grab the other holes within the system. Currently 0.138. We need to make them 0.1875. Done. I need to move this 1 inch to the right using my steering wheel. Done. The other thing we need to do is we need to decrease this by 1/8 of an inch. Done. Last but not least, I'm going to eliminate this piece here. going to do that very quickly and easy. Done. In a matter of 30 seconds, I was able to make all those changes. I'm now ready to save this out and move this on to production with these changes. Ask yourself, how long would it take me to do this type of operation in my current CAD system? I challenge you to make those changes as fast as I just did for you right here. Not impressed yet? Let's take a look at another file. I'm going to go ahead and open up a Solidworks file. We're going to do the same thing. It's going to get translated in. And just like with any other CAD file, when you translate something in, the file is a dumb solid. There's not a whole lot we can do with it. In this particular case, I need to make a change to this round. Deep inside, we need to increase the diameter of this. We need to decrease the chamfer size, and we need to increase the overall diameter. How would you do that with your current CAD system today? With synchronous technology, it truly is 100 times faster, and let me show you. First thing I'm going to do is grab this. The system only recognizes this round. I'm going to grab it. I'm going to increase it to 60 thousandths. Next thing I'm going to do is reach in, grab this whole diameter. The system automatically says it's 0.047. I'm going to change it to 60 thousandths. Quick, done. That easy. I need to grab the diameter of this piece. System says it's 0.193. I'm going to change it to 200 thousandths. Done. That quick. Last thing is this chamfer. It's going to recognize a chamfer. We need to change it to 40 degrees. Done. Once again, in a matter of seconds, I was able to make changes to this particular piece. This is something that you truly have to ask yourself, how would I handle those changes without synchronous technology? I challenge you to be able to do that. Still not impressed? Let's take a look at another model. This time I'm going to look at an Inventor model. We're going to go ahead and open this part up. And what you're going to see here is we have a flange. We're really going to impress you. This happens all the time. You open the flange up, or you pull a flange off a McMaster car, or someone sends you a system and it's a dumb model. You need to make changes to it. Yes, it would be easy to redraw, but why can't we just use synchronous technology? I need to increase the size of the inner diameter and outer diameter, and I need to change it from a 4-hole flange to an 8-hole flange. How would you do that with your current CAD system? Well, synchronous technology is extremely easy. Let's take a look. First step, I'm going to change this to 8.5-inch diameter. I'm then going to click on the outside, and I'm going to change that to 11. Next, I'm going to grab these 4 holes. With synchronous technology, this is extremely easy for us to do. I'm going to change the hole size to 0.50. Then what I'm going to do is use the steering wheel, snap it to the center. We're going to go ahead and copy these holes. With synchronous technology, this is an easy operation for us to do. I'm going to snap it to 45 degrees, and done. That quick and easy. We've changed this 4-hole flanged process into an 8-hole flange. We've made some changes. We've done it very quickly. That is the power of synchronous technology. Let's take a look at using synchronous technology with a simple assembly, something that we would do every day. I'm going to go ahead and close this file. What I'm going to do here is I'm going to say, let's just create an assembly from scratch. First thing I'm going to do is I'm going to drop in a base plate of this assembly we're going to create. We can see that the base plate has some threaded holes, and I need to bring in a part that has been sent to us from Solidworks. So first thing I'm going to do is I'm going to locate that part, and I'm going to open up the Solidworks file that was sent to us. Here's a Solidworks file that was sent to us. We need to make some changes to this. One of the things I need to do is to verify the hole sizes here. I'm going to select this hole. It's 1.024. I actually want to make it 0.875. Notice that both holes change that quick and easy. I'm going to verify the rounds here. I want to make these 1.125. I'm going to increase the gusset by 1/8 of an inch. And we're going to decrease the size of the overall height of this piece. And we're going to do that 0.50. Everything looks okay. I'm now going to go ahead and save this. We're going to close that file. Now what I can do is bring this support file in, do some quick connections. Very quick and easy. Make changes to this file. Need to copy this over to the other side. We're going to do a copy and a paste using simple window commands. Once again, with just a few clicks, we're able to quickly make this model. Next piece is we have a roller piece that fits between here, and it happened to be sent to us with an Inventor file. So I'm going to go ahead and open up this Inventor file, take a look at it, run the translator, and see if there's any changes that we need to make to this file. Looking at the file, it's currently at 3175. I want to make it 2.75. That quick and easy. I was able to make that change. And I want to decrease this 0.25 inches. We're going to go ahead and save this file out. Now I can bring this into my assembly. Once again, very quick and easy. Make the changes accordingly. It's very quick and easy using synchronous technology. Center this piece. And just like that, I was able to create an assembly. Last thing we're going to do is drop our bolt into place. And we'll go ahead and pattern that bolt around. So you can see with synchronous technology, it's extremely easy to make changes and to utilize in a truly multi-CAD environment. But one of the questions I have for you is, can your CAD system do what I'm about to show you? We decided that this gap is actually too big, and we need to make changes to this. What I'm going to do is I'm going to go to what we refer to as a face selection. I'm going to go to a top view of this, and I'm going to go ahead and make changes to this. And I want to go ahead and pull this in so that equals with what we're looking at here. If we wanted to, we could pull this in more, but that seems to be okay. The other thing I want to do is I want to increase this. I want to increase this 40 millimeters. Done. I want to increase in this direction 10 millimeters. Done. The last thing is we're taking a look at it. I'm very happy with what I see. I need to add some rounds to the lower component. It's very easy to do. And very quickly add some rounds. And we're going to make this 25 millimeters. So that quick and easy, I was able to make an assembly with some simple changes utilizing synchronous technology, something that would be very difficult for you to do in your current CAD solution.
And here it is.
We are focused on the capability to really help designers and engineers design better. Solid Edge, design better.